So first of all, before we get too far into it, if anybody would like to link up with me on LinkedIn, especially if you have a particular area of interest in the AI arena you'd like to either speak on yourself or get me to find somebody to speak on, I'd love to hear from you. So go ahead and grab my LinkedIn, and I would happily accept your request to join the network. And you can reach out to me, and we can dialogue on LinkedIn or have a phone call, whatever you like. So real quickly, who am I? I'm basically a long-term technologist. I've been in the industry about 40 years, mostly in architecture roles and executive roles later on. You can tell which I like more. I like the tech. And so I've done a lot of CTO work. I've done a lot of chief analytics officer work. We hacked the stock market. We did all kinds of cool things. So I've been involved with machine learning through a couple of what they call AI winters, where it wasn't the hottest thing on the block. You go up and down in terms of interest. And we are definitely not in a winter right now. We're in the opposite, AI summer. So it's all a lot of really interesting stuff to talk to. So I have two conversations. One is AWS has a new set of services, Amazon Web Services, that provide generative LLMs. So you can go and build that directly into your applications running on AWS. And so we could talk about that. The other thing is sometimes we want to understand, I'll just skip the best pictures worth 1,000 words. Okay, get a clue. Is your LLM smarter than a third grader? Okay, so the idea is we can talk a little bit of techie, or we can talk about AWS services. So show of hands, AWS services. 1, 2, 3, that's it. And 3. Of course you'd want to know, right, Bhaskar? And the other is your LLM smarter than a third grader? So, oh, obviously, okay, well, let's do that. So everybody has probably played the game Clue. Who hasn't played Clue? Oh, wow, you guys got it. It's a great board game. It's been around for like 50 years. So what is it? Well, there's a map, which is your where, and you've got a lot of different rooms. And you've got the who, you've got different people. And what you're trying to discover is who murdered the murderee, and what did they use? Did they use a candlestick, a knife, a gun, whatever, right? And the idea, the way you play this game, and you have 3 or more players. So what I've done is say, well, what if we were to hypothetically, and I might build this app because it could be fun. What if we had Llama 2, which is one of the most popular LLMs out there, large language models, and we had Jurassic 2, which is also very popular, and we have a third grader. If we were to put them in a situation where they could play this game of Clue, who would win? I'd like to know, right? So that's why I might write this app. So if I was to write this app, and that's the point of this presentation, what would it take to write an app like that? What would I need to do? Well, the first thing is I have to take the game rules and I have to basically feed them to the LM. That's done through embedding. So embedding is taking words and creating a numeric vector, because computers work on numbers. They don't work on words, right? So we take words and we tokenize them. And then we provide that embedding to the large language model, and it uses all of the other stuff it's been trained on to make sense of that embedding, those game rules. So how well will Llama or Jurassic or the third grader understand the rules of the game? Okay, so that's the first thing we do. Clearly, when the third grader is not embedding them, it's going into their brain somehow. Not that we really understand how that works, but we try, right? And then you have something in this game called detective notes. So as you learn about the clues in the game, you can start marking what you know on these cards. So each card itself can also be an embedding. So that means as the game progresses, we're learning more, we embed that knowledge, and we send it to the LM. So we're building a context, right? So the game rules plus the current card, Llama will know something about the game. Then we get clues, and the way the game is played is you get dealt some cards, and the cards tell you something, and the who did it, and where they did it, and what they did it with are in a little packet. You don't know what's in that card set, right? But you know what it's not because you've got those cards in your hand, and so do the other players. And so the idea is each of these players knows a little bit that the other players don't know. And there's some rules for exchanging information and whatnot. But that is as well something we embed, okay? So there's a lot of embedding going on here, right? That's called building context, and that's what it takes for a large language model to do something useful. Then we do the play. When you play the game, like most board games, you've got a position on a board, right? And you have a turn. In this case, there's 3 players, so round robin. And you have a set of available actions, right? And what we do is we wire up this application so it calls native functions instead of semantic functions. There's 2 different things. The semantic function is I got a prompt like, make your next move. What would you do next? The generative AI says, oh, well, I would like to do, and it would do one of these actions. So first they roll the dice, they make a move, they can move into a room. When they're in a room, they can suggest that somebody did it, or they can make an assertion that somebody did it. If they can make an assertion and they're right, then they win the game. If they make an assertion and they're wrong, they're out of the game. Okay? So the idea is that if we were to wire this all up and we were to run this, who would win? And how many times would they win if we did it lots of different times? And by the way, we could replace the 3rd grader with another LLM. Or we could have the same LLM, maybe Jurassic, just 3 different contexts. So there's lots of different ways you could organize this app to do something kind of interesting. Either you could be a participant, you can act the 3rd grader, or whatever. Or you could just play it over and over again and see the different ways the game plays out. And it'll always be a little bit different because there's die involved. What they're doing is you're rolling a die to make movements. And you're choosing where to go with your movements. So there's a little bit of strategy involved. How much will these LLMs be able to develop an effective strategy? And so what we want to do is look at all of that and what happened, and we want to measure it. And by measuring it, we can understand the efficacy of the different models. And you're saying, well, that's all fine, but what the hell's that got to do with making money? How can I monetize that? Well, think about the kinds of things you do in business in terms of your engagement with consumers or other businesses if it's a B2B model. You're playing a game. So if it's a negotiation for a better price, or if it's a negotiation for a particular concession of some kind in terms of the term of a product you're buying, any of those kinds of things that you would normally do, well, you can imagine maybe a gamification of that. You build a model, and then you can have people coming to your site and engaging in that game. Hopefully, without you having to spend a lot of money, but at the same time, what are you doing? You're trying to get the business, trying to give them an optimal deal. So the more that large language model knows about your particular business, about your particular parameters of what constitutes a good deal and what constitutes a bad deal, then you can take the human element out of that. What's the most expensive thing in business? Most businesses. People, right?
Payroll.
What?
Payroll.
Payroll, exactly. Well, LLMs are pretty inexpensive payroll. They're fairly cheap compared to people. So at the end of the day, it's doing these kinds of thought experiments and fun little games that can take us to a better understanding how we can leverage the tools in our business activities, or just have fun building games.
Like a more accurate price quote calculator.
Price quote calculation, will this increase the dimensions of that to maybe delivery timelines, preferred shipping, all those other things that come into play. They're all kind of intertwined. There's some combination of those things, right, that would be good for both parties, finding that. That's game theory, right? And game theory is a whole other subject. And not one LLMs have been particularly addressed to. There is some of it going on. By the way, just full disclosure, there are academic papers where they do just this. They train LLMs by putting them in this kind of competitive process, and they keep a memory of what they did, and it's that memory they can rely on to develop strategies for future games. So anyway, that was a short little presentation I thought you might get a kick out of. But it's important that when you look at using large language models in your business, that you clearly understand what the benefits of those models will be and what your objective is. What are you trying to do? How is it going to improve either your customer's experience, their perception of the value that they've received from your business, or it's going to lower your costs, the payroll costs, or it's going to lower your manufacturing costs. There's all sorts of ways that these models can be used if they know enough about your business. And what I want to do is just bring gamification into it. I'll come back to you.
Do you have any insight on how AI can, the technology of AI can be leveraged in CRM, for example?
Well, it's used in CRM today in lots of interesting ways. For instance, one of the things that, I don't think Bhaskar touched on this, but one of his colleagues did a demo where they were using their generation to do better emails and response. So for instance, if you talk about CRM, it's engagement. It's all about engagement, right? So how much of that engagement can be automated without the customer getting upset? We've all done the phone menus, right? Anybody love those? No, nobody loves those. It's not much better when you're talking to an agent if it's not really good. And of course, there have been some really good agents. Google came out with some, so on. So in a CRM, if I was to pick one thing that's most, I've seen most used, is it looking at all of the conversations that are coming in to pick the ones that you should pay attention to right now. Tone. Who's pissed off? Who's ready to buy? Right? Those are things that as somebody managing, a sales organization or as a salesperson, you need to know. And what's more, as a sales manager, which I've done a number of times, how's it looking with my team? Do I have salespeople who are doing better than other salespeople in terms of measuring their relationships with customers? And if they're doing a better job, how can my other sales team members learn from them? It's not about punishing the people who aren't doing well. They may just not know all the tricks. Why is Joe doing so well and Fred's not doing so well? That kind of thing, right? There are loads of other examples, but it's actually an area with a lot of sort of implementation going on because it's a direct financial benefit to the companies who implement it successfully. The flip side, there's risk. If you do it poorly, then you can suffer loss of customers, you can suffer loss of deals. It's just not a good thing. Oh, you had a question.
Yeah, is LLM a subset of NLP? And can you build
Natural language
yeah.
processing, NLP. If you look at what an LLM does, it's a statistical model, right? What is it doing? It's looking at a corpus that's been ingested as embeddings, the vectorization of large amounts, trillions of tokens. It's a lot. And what it does is it looks for statistical relationships between these vectors in terms of their closeness in a multidimensional mathematical space. Lots of fancy words. What it means is that it's using semantics rather than word matching, okay? And in that sense, that statistical relationship is what's used to do the generation. What comes next is statistically determined. And there's some more to this that I'm leaving out, but that's the core. NLP is a little bit different. It's more heuristic by nature, but they do have, it depends on what branch of NLP you're working on. I would say that when we talk about how people use the tools, NLP is basically a way of taking human readable text or spoken words, whatever, and trying to understand it. The LLMs are not so much about understanding, but being able to generate a response. There's a subtle difference there.
So is ChatGPT more of an LLM?
ChatGPT is an LLM.
But now it has that processor built in, right? Because, I was just playing with that tool last night, the AI speak to you version, and it sounds incredibly natural.
Doesn't it? It's very good.
Blows me away.
Yeah, and the thing is that when a lot of what we mistake for intelligence in people is their ability to have assimilated, just like the LLM, a lot of information and understand how all those information are related to one another and their ability then to do something with that. Write a poem, write a book, write an email, respond to a question.
Not quite conversational as much so as it's responding to your inquiry and then trying to find out what other information you want it to ask or you want to ask it.
Yeah, there's LLMs generally do three things. the table stakes for LLMs is chat completion, which is that dialogue. Text completion is you're typing along what's the next word that you're looking for or phrase, right?
Or
You see
the
that?
ability to understand misspellings. You write tent and you write like T-O-N.
Yeah, that's low-hanging fruit because the contextual, misspelled words can be contextual tokens themselves, and they commonly are. So, yeah. And then the third thing is summarization, which is huge. You can take a very large chunk of text, drop it in, and ask it to summarize, and it will use its underlying understanding of the relationship of all these, the vectors again, all these pieces of commonly associated tokens, which are words ultimately, and generate a summary of that, taking out all the fluff, right? It can look, using statistics, it's reducing the word count, summary, but it's retaining as much of the information and presenting it in the most commonly and most efficacious way, right? So that's summarization. Then there's some other things that LLMs do, but those are the textual LLMs. There's also things like stable diffusion and other visual, the artistic side of things, right? Where they're, doing photorealistic rendering of items. And that's, again, they're taking images and they're vectorizing them. But yeah, so
Mid-Journey is also on LLM?
which one?
Mid-Journey.
Yeah, sure. Almost all of the models that are getting attention today are LLMs, which basically are a neural network on steroids, and with some very interesting stuff on top of vectorization.
I'm confused a little bit. Where does NLP fall in this spectrum of what you just
That's actually a talk for a subject for a talk. I think I'd rather take the time to actually build a presentation and answer that. I'll take that under, yeah, let's do that. Because it's been a long time since I actually thought about NLP from that perspective. So do that, yes?
So about playing Clue, for example.
Yes.
One thing you have to do, right, is decide when you're going to make your final.
Make your assertion or yeah.
So would that be something that LLM itself is capable of deciding? Okay, when am I confident?
Yes, that is absolutely what we were. Yeah, because it knows the rules. Well, it's embedded the rules. How well it knows it? Well, it's got this enormous body of literature that it's sucked in. A lot of that is about games. It's read the entire internet. It knows a lot about games, right? So it would say, oh, okay, when I read the rules and I understand I make an assertion and there's a risk. If I make the assertion too early or make it later, that's a statistical thing, isn't it? So one of the things you might want to, understand is how well the LLM can use what it's read on the internet and it's simulated in making a decision like that. But yes, it would make the decision to answer your question. Any other questions? Okay. Yes.
Are you gonna go on?
Well, what time is it? How early are we going here? It's a little after 12. I did have another presentation, and that's on the AWS stuff. But we can, if you guys want to go for another 10 minutes, I can do that, or we can break and go have lunch. What would you like to do? It's up to you.
I'm curious about the AWS.
All right, I'll make it really quick because I like them short and sweet, right? I am a big fan of AWS, and I actually build systems using AWS services quite a lot. And most of my experience is in fintech and casinos, things like that. So we want to have secure systems. So one of the reasons I was interested in AWS has always been a big deal in machine learning, right? Is the new LLMs they're offering is, hey, those are built on top of that platform. It's secure, so it would be a very straightforward way for me to extend my existing AWS application stacks with generative AI solutions. And it would all be secure, we hope. So they have a few models, and I'm a fan of putting it in a chart, right? Making it real easy. So we've got the AWS Titan model. That's their own foundational model for LLM. We've got Jurassic from 821. We got Claude from Anthropic? I forgot. Anthropic, thank you. And Command from Cohere, and of course, Llama from Llama 2 from Meta. And so I want to say, well, here's the features. Let's put this in a little product matrix. Chat completion. So Jurassic doesn't do that. It does summarization. It actually does a little bit, but they don't make a big deal of it, so I took them off. But all of these guys, chat completion, sort of table stakes. Text completion, typing it yet. Summarization. Llama doesn't do that. It doesn't do text completion either. So not all LLMs do all the same things. And then there's some other things that you can do, like embeddings. It's actually possible in these, but not necessarily in the AWS platform. So you've got AWS reselling these models, right? And they kind of put a wrapper on it, and they don't necessarily offer all of the features and functionality that you might get if you went directly to using Llama or one of the other guys. Semantic search. Remember we talked about embeddings, right? So if you took a bunch of embeddings and put that on top of a big database, you could use it to do search, not just by keyword, but by the relationship of things. And that could be images, like tennis shoes, as opposed to the term tennis shoes. You might actually show shoes, and you could then ask people could say, well, I want shoes that are used for tennis, and it might actually ask you to pick some pictures of the kind of shoes you like, and it might find the tennis shoes that are closest to the one style of shoe you chose, that sort of thing. So semantic search is far more powerful than keyword search. And then finally, we got augmented retrieval, which is something that AWS is doing, where they're saying, look, you got your database, right, in your organization. You got all these data. Let's go through those databases and vectorize a lot of it and put that into the search engine so that you can actually augment the returned information by pulling data from your data sets related to a given semantic search. Everything they know, the company knows about tennis shoes.
I think Anthropic is a company they just bought, so I'm guessing it's going to be on AWS.
I didn't know that Anthropic was bought by AWS. All these are on AWS. These are all part of Bedrock.
Oh, so that line that you said not on AWS, that's just for training?
Meaning that the fine-tuning training isn't available on AWS, but they do offer it if you go on to Anthropic's site directly. But all of these LLMs are available on AWS. And it's kind of cool. You can go into their dashboard and you can just pick which one you want to talk to. So for instance, chat completion, you can do with any of those 4 platforms directly in AWS. And you can switch between them easily. And why is that important? Well, in my example of the game, I could actually build an app on AWS that plays Jurassic and Claude and Command, all these against each other. Now, there's some interesting differentiations here, like max tokens. One of the things that is most important when you're working with prompt engineering and you're talking to these LLMs is you've got prompts, and as you go through a series of prompts, you're building up a history. And in ChatGPT that you played with, when you're doing that in a chat window, all of the previous chat is being sent along so that it has a complete context. But at some point, you reach a limit to the number of tokens and it starts chopping stuff off. It limits about 8,176 tokens, or about 7,000 words, about 6,500 actually words. Here, max tokens, you see these are 8K, 8K. Look at what these guys did, 100K. They have the largest contextual sort of bucket you can work with. 100K is like 70,000 words. That's a big document. So you could drop the whole document in, and it will actually do a good job with that. That's their claim to fame. You might not need that, or maybe that's the thing that makes your application pop. And then some of these other 4K, which is old school.
There's someone that just rewrote a model for how many words an AI model can actually understand, so all those numbers are going to jump.
Oh, they're all in a foot race. All of this is so new, and it's on such a steep trajectory in terms of feature functionality that a year from now, all these numbers will be totally obsolete. And months to month, things are changing. It's wild. Parameter size, not all of them published what their parameters were, but training on 52 billion, 13 billion, 70 billion. these are these are the parameter inputs. So anyway, thought that was kind of fun. And then there's also the visual side of things on AWS. They use Stable Diffusion. So you can actually go ahead and you can provide images, ask them to merge them, do all kinds of interesting things with images. I don't know if you guys have played with that. It's not something I'm heavy into, but it's cool. So again, from your AWS app, you can use Stable Diffusion. And by the way, all of those are services. So you only pay for what you use, which is kind of nice. So the table stakes, as I mentioned, chat, text completion, and then summarization. Bettings, I talked about that. Semantic search, talked about retrieval. Underneath this is another service. Calling a service is being a little flippant because it's actually a number of services called SageMaker. So for years on AWS, we've been able to build and deploy very sophisticated machine learning models, right? All of that's still there. You can use SageMaker to develop your own what they call foundational models, which you can use from Bedrock. So you might use SageMaker to auto-tune, meaning increase the understanding of an LLM with your particular business parameter, data, whatever. Like, I tell you a story. My wife works in the welfare department in the state and is a case manager. And what they have to do is they've got literally thousands of pages of documentation about the rules and the interpretation of the law. The law might be 1 page, the interpretation could be 5 pages, right? And they need to use these interpretations to decide what actions they're allowed to take on different cases. And then if they get it right, then the federal government pays a lot of money for the program. If they get it wrong, the federal government withholds the funds. So it's important they get it right. And so what they do is they push these people through these enormous, 12-week programs to even get to the point where they can start working. And they still get it wrong a lot of the time. I keep telling her, wouldn't it be cool if we just parked, an LLM in front of that?
Especially when that's a primary financial motivation.
Yes.
Throw that in the car.
Yes, wouldn't that be cool, right? Unfortunately, because she works for the state, I can't do it. Or I would. It would be just a very cool thing to do. Trainium, if you have a large model and you want to train, they have a service called Trainium, which uses hardware custom designed to do neural net training. And it's a lot less expensive than running it on standard EC2 instances and whatnot. So these are machines with these large, they call them GPUs, but they're not really doing graphics processing. They're there to do learning. Massively large models can be done. And then once you have a model and you have data coming in that the model is going to operate on, that's called inference. And so they came up with this name, inferentia. And what it does is it lets you process a lot of incoming so that you can then pump out results more quickly. So if you wanted to build your own large foundational model and then do inference with it, you could use AWS tools. So working with some folks in the UAE, United Arab Emirates, and they used 18% of Amazon's available GPUs for 3 years to build their large language model. It's like, wow, you imagine? All right, that's it. Any questions on the AWS stuff? No, pretty clear. All right, well, let's break for lunch. I don't know if, for folks who haven't been here before, they do a great job of the buffet. And it's, of course, free, so go have a bite on us. Thanks, guys.